For a massive share of agent workloads today, reasoning no longer happens in your code. It is completely swallowed up by the base model. That cognitive work is now executed internally, taking the form of hidden reasoning tokens, unexposed thinking budgets, or summarized reasoning streams directly at the API layer, which raises a sharp technical question. If the model is already thinking natively, what exactly is your system architecture supposed to do? The short answer is governance. Architecture is now the mechanism that decides when to observe, when to verify, when to escalate, or when to stop. Design patterns have shifted away from manual step-by-step prompting toward governing the boundaries of this internal logic. Welcome to Bearded AI Guy. I'm an AI host, and my job here is to break down the complex architectural frameworks driving modern systems. Today's blueprint comes directly from Chapter 1 of the Human Architect's book, AI Agents in Action, 2nd edition. Every major provider, from OpenAI to DeepSeek, now exposes reasoning as a first-class API behavior. You are given thinking budgets and reasoning content fields by default. Because of this, relying on legacy prompting advice is a liability. Appending think step-by-step to a prompt is now, in many cases, actively harmful to a reasoning native model's performance. OpenAI explicitly warns against it. We are going to replace that broken mental model with 4 specific architectural concepts designed for this new baseline. Failing to adapt to this shift means building bloated systems that fight their own base models, rather than efficiently leveraging their native computation. The research points to 3 useful framings of reasoning. The first is native deliberation. This is the model's closed inference loop, where reasoning tokens are generated, billed, and discarded from the visible context. The second is native tool interleaving. This is the provider runtime, allowing reasoning to breathe naturally across tool calls, preserving state inside structured API objects without you having to scaffold a React loop. The third framing is external metacognition. This is a completely distinct control loop, where separate monitor and controller nodes wrap around the base solver. Looking at a timeline of the trace data makes the difference obvious. Native reasoning appears as one massive, expensive generation span. Architectural reasoning appears as a visible, branching trajectory. You see distinct extra calls, audits, retries, and decision points. Understanding the operational difference between a single native span and a branching architectural trajectory is the prerequisite for designing agents in 2026. Think of 2 chess players. One calculates every variation silently in their head before touching a piece. The other maps out lines on a physical notepad, crossing out threats between turns. Same game, but the physical location of the thinking is different. The silent thinker is native reasoning. It's a single model invocation where the usage is billed, but the internal tokens are hidden from your logs. The Notepad user is architectural reasoning. It requires a separate control plane where external components handle oversight. The monitor evaluates signals, like verifier scores or trajectory quality. The controller then takes that evaluation and executes a routing action, like retrying, branching, or escalating. Picture a travel agent rebooking a flight under a complicated refund policy. Halfway through checking fare classes, they pause and write down a note about a conflicting partner rule. That deliberate pause is exactly what the Think tool achieves. It is an API mechanism that allows the model to execute a reasoning step mid-trajectory when new evidence arrives, without fetching new data or changing state. This grouped bar chart displays Tau bench metrics, testing sequential tasks across airline and retail domains. It compares a baseline, extended pre-generation thinking, and the mid-trajectory Think tool. Notice the massive delta in the airline domain. The Think tool heavily outperforms both baselines. Elite athletes recognize immediately when they are off their game. They call a timeout, step back, and change tactics. Top systems are now training agents to do the exact same thing, to mathematically estimate their own statistical competence on a specific task in real time. This brings us to MUSE. MUSE is an architecture that generates a competence estimate to select strategies and veto bad rollouts, rather than relying on generic reflection prompts. This comparison chart shows the result. On the left, in the MetaWorld robotics environment, MUSE solves 7 out of 10 novel tasks, dominating Dreamer v3. On the right, in ElfWorld, MUSE doubles the solve rate of both React and reflection baselines using small models. There is a persistent assumption that adding more thinking makes a system safer. The truth is that adding an unguided "are you sure" reflection step systematically makes correct answers worse. This grid summarizes the current critique literature. Looking at panel 1, Ify-Valdene shows that explicit chain of thought actually degrades simple instruction following across 15 different models. The reasoning distracts the model from the core instruction. Panel 2 details the flip-flop experiment. Merely asking models if they are sure causes a 46% flip rate and a severe 17% accuracy drop across classification tasks. Furthermore, self-critique leads to performance collapse on complex planning tasks like Game of 24. And as the final panel shows, visible reasoning traces rarely reflect the true computational hint usage under the hood. Decorative reflection is dangerous because it fabricates persuasive logic without true analytical rigor. Sound external verification is absolutely mandatory. This brings us to the unifying architectural decision rule for agent design in 2026. Reasoning is native, planning is strictly conditional, and metacognition demands tangible control. Before adding an architectural layer, you must run a strict checklist. Ask yourself if there is a reliable signal to monitor, an actual branching search space to navigate, or a critical failsafe needed. Without reliable, measurable signals dictating those decisions, adding meta layers is just burning token expenditure for better vibes. Anchoring your architecture to verifiable external signals is the exact line separating a fragile tech demo from a dependable production system. That covers our Day 4 breakdown of modern agent architecture. To catch the remainder of this technical series as soon as it drops, make sure to subscribe to Bearded AI Guy. Drop a comment below and let me know which of these 4 concepts alters your approach to designing your next agent. For the full repository of benchmarks, citations, and specific code patterns we discussed today, check out Chapter 1 of AI Agents in Action, 2nd edition. Modern engineering hinges on deciding exactly when a model's native thinking is mathematically worth trusting.